Okay, dear students, today we will discuss about Young's double slit experiment. Dear students, you already know that interference. It means it is a phenomenon of redistribution of energy of waves when number of waves are in a superimpose. It means superimpose means so one wave so fall on the another wave. Yes, so here intensity increases. Suppose one wave fall on the another wave, it means a crust fall on the trough or a crust fall on the crust. If a crust of one wave fall on the crust of another wave, so here intensity increases because of resultant magnitude increases, and the trough of one wave fall on the crust of another wave. So here amplitude decreases, it means intensity decreases. The same concept here we consider that in Young's double slit modulus, first we consider that so S is a source. Yes, so source, it means we consider that a bulb. It means a light source. Okay. And here we consider that two slits. Yes. So two slits means so this one is a first slit S1 and this one is second slit S2. And here some distance we consider that one screen. The distance between a slit to screen we consider that generally D. Okay, so this source continuously produce waves S when these waves are passes through this slit. Okay, so here suppose we consider that this one is a crust. Okay, so here crust, and this one we consider that trough, and this one is a trough. Okay, so crust and the trough, and here also we consider that one crust and the trough. Yes, so crust fall on the crust and trough fall on the trough, or crust fall on the trough of one wave, or trough fall on the crust of one wave. So here, so one wave is overlap with, or one wave fall on the another wave. So suppose here we consider that this one is a crust, okay, and this one is a trough, and here we consider that so from second slit, so crust, and this one is a trough. Okay, so another one crust. Okay, and here also we consider that one crust come from S2 and a trough. So this one is come from S1 slit, and another one we consider that one trough from S2 slit. Okay, so this one is S1 and this one is S2. Okay, so here crust fall on the crust and trough fall on the trough. Suppose crust fall on the crust or trough fall on this trough, so continuous. So one wave overlap with the another wave. Suppose a crust fall on the crust or trough fall on the trough. So here we get a bright fringe. On the screen, here we get a bright fringe. Suppose. So this one is a bright fringe. Okay, so center, exactly center, we consider that one bright fringe. Why? Because so here, so crust fall on the crust and trough fall on the trough. So here we get a one bright fringe. Next one, here crust fall on the trough. So here dotted lines are there and this one is a straight line. Okay, so crust fall on the trough. So crust fall on the trough. Yes, so here we get a dark band, and here also same. So crust fall on the trough, crust fall on the trough. Okay, so here we get a dark band. So this one is bright and this one is a dark band. Okay, so bright band and dark band, and here center we consider that a bright band, and afterwards we consider that one a dark band. Yes, so bright, dark, it means so here this one is a dark and this is also dark. It means so center crust fall on a crust or a trough fall on a trough. For example, here we consider that this one is a so one waves and another waves. Yes, so another waves. So here, so crust of one wave fall on the crust of one wave and trough of one wave fall on the trough of another wave. So this reason here we get a resultant amplitude increases. It means intensity increases. So this reason here we get a center bright band. And next one, so here, so this one is a crust and a trough, and here crust and a trough. It means the crust of one wave fall on the trough of another waves. So here resultant amplitude decreases. So when a resultant amplitude decreases, it means intensity is also decreases. So this reason here we get a dark band, and here also dark band. Yes, okay, so center we get a bright band, afterwards so both side we get a dark band. Again we get a bright and a dark, bright and a dark. The same thing here also we consider that bright, dark, bright and a dark. So this one is a continuous bands are arising on a screen. So same way, center bright, dark, bright, and here also another side also we get a bright, dark, dark. It means alternate bright and dark bands appears on a screen. Yes, so this one we consider that a Young's double slit experiment. So first one we consider that a monochromatic source. So this one is monochromatic source. Okay, so this source waves passes through this S1 and S2 slit, and here so this one is a wavefront. One is crust to trough. Okay, so first one we consider that crust trough, and crust trough. It means so here so number of waves are overlap to each other. It means one wave fall on the another waves. Suppose a crust fall on the crust or trough fall on the trough. So here we get a bright band, afterwards a dark. It means a crust fall on the trough. So here we get dark band and a dark band, bright, dark. It means alternate bright and dark bands are formed on a screen. So this one we consider that a Young's double slit experiment. And next concept we consider that a fringe width. Okay, so fringe width means the distance between. Suppose here we consider that so this one is a bright band, and this next one we consider that a dark band, another one is a bright band, so dark band and a bright band. Okay, so this one is bright band and this one is a dark band, so bright band and a dark band. Okay, the distance between two bright bands, the distance between two bright bands or distance between two dark bands. If you consider that distance between two bright band or two dark band, so this distance we consider that a fringe width is the distance between two bright band or two dark band. So this one we consider that a fringe width is so fringe width, okay, the distance between two bright band or two dark band. So this distance we consider that fringe width, or we consider that here two dark bands are there, in between distance we consider that this one is a fringe width. Generally fringe width it is represented by the beta. And here also we get a fringe width, so this distance we consider that fringe width, so this is also represented by beta. Yes, so this reason the fringe width means it is a distance between two bright bands or two dark bands. So that's when we consider that a fringe width. Okay, so here we get a number of fringes. So first one is a center bright fringe, and next one is a dark band, dark bands. First one is center bright band, and next dark bands. Bright, dark, it means alternate bright and dark bands form on a screen. Okay, so this one we consider that Young's double slit experiment. Next one we consider that expression of fringe width. Fringe width means it is a distance between two bright bands or two dark bands. So that's one we consider that fringe width. Okay, so next one